Welcome to the deep dive. Today, you're joining us for something pretty cool. We're digging into the story of a dinosaur called the Apatoraptor.
That's right. It's a relatively recent discovery in paleontological terms anyway.
Exactly. And our main source here is the Wikipedia page on it, which, it lays out the discovery, the classification, its features,
Yeah,
the whole shebang.
it's a good starting point. It covers the essentials well.
So our mission, basically, is to figure out, why is this Apatoraptor a big deal? What's its significance in paleontology? And maybe what does its story tell us?
And there's definitely a story there. Even the name gives you a hint.
Right. Apatoraptor, deceptive thief. That alone makes you think, okay, what's the twist here?
Absolutely. Its journey from, well, just another bone in the ground to a recognized species is kind of fascinating. It really shows how science works sometimes.
Okay, so let's get into that journey. Where did it start? The source is 1993.
Yeah, 1993. Near the Royal Tyrrell Museum in Drumheller, Alberta. That whole area, the Horseshoe Canyon Formation, is just, packed with fossils.
Yeah. A real hotspot. So finding another skeleton might not have seemed like earth-shattering initially.
Probably not. And in fact, the Wikipedia page mentions this specific find was initially logged as just an unimportant ornithomimid specimen.
Okay, hold on. Ornithomimid. Those are the sort of ostrich-like dinosaurs, right?
Yeah.
Fast runners, fairly common.
Exactly. Bird mimics. So, yeah, the initial thought was, oh, it's just one of those, something paleontologists were already, pretty familiar with.
So because they thought it was common, they didn't rush to work on it.
Not at all. The actual preparation, cleaning the rock off the bones didn't even kick off until 2002.
Wow, like 9 years later.
Yeah. And then, get this, they almost immediately stopped.
Stopped. Why?
Because they didn't think the skull was there, which often lowers the perceived importance, So this potentially new dinosaur basically got put in plaster and, well, shelved.
Seriously, just put away.
For another 6 years, yeah. It really shows how those first impressions, those initial assumptions can sometimes, slow things right down.
That's kind of wild. A whole new species potentially just waiting in storage. So when did things change?
Well, things picked back up in 2008. Research restarted on this specimen.
And that's when they had the aha moment.
That seems to be it. They looked closer and realized, wait a minute, this is not an ornithomid. This is something different, something new.
Incredible. And that specific fossil, the main one they used to define the species of the holotype, right? It's still at the Royal Tyrrell.
Yep, specimen TMP 1993.051.0001. It's there, kind of a testament to this whole winding discovery process.
So it finally gets recognized, and then it needs a name. That's where deceptive thief comes in.
Precisely. It wasn't formally named until 2016. Gregory Funston and Philip Curry were the ones who published it. Apatoraptor pinnatus.
Okay, break that down. Apatoraptor, you said deceptive thief.
Right. Apate was the Greek goddess of deceit, and raptor is Latin for robber or thief. So it's a direct nod to how the fossil kind of, tricked everyone for so long.
I love that. It's like a little paleontological joke built into the name. And the second part, pinnatus?
Pinnatus just means feathered in Latin.
Feathered. Okay, so we know it had feathers. How?
The source mentions quill knobs found on the ulna. The ulna is one of your forearm bones.
Right. And krill knobs are like little bumps where feathers attach.
Exactly. Bumps or ridges on the bone where strong ligaments anchored big feathers. So pinnatus tells you straight away this was a feathered dinosaur, likely with, well, some kind of wings.
Wow. So the name itself tells a mini story. The deception and the feathers.
It really does. And finding those quill knobs is pretty significant. It helps place Apatoraptor firmly within that big group of feathered dinosaurs.
And more specifically, where does it fit in the family tree?
It's classified within Oviraptorosauria.
Mm.
The egg thief lizard, so that name's a bit misleading too.
Right, often bird-like features.
Very bird-like. And within that group, it's in the family Cynegnathecidae.
Cynegnathecidae, I know that name. They often have those toothless beaks, right?
That's a common feature, yeah. Suggests some specialized diets, maybe. And Apatoraptor is considered quite derived within that family.
Derived, meaning like more evolved or specialized compared to earlier members?
Sort of, yeah. Think of it as being on a newer branch of that family tree. The analysis suggests it might even be a sister species to Elmosaurus.
Sister species. So, like, very close relatives sharing a recent common ancestor.
Exactly. Like finding two close cousins on that particular branch of the Oviraptorosaur family tree.
Gotcha. And this holotype specimen, the one at the museum, it's just the ulna with quill knobs. Or is there more?
Oh, there's more, even though it's partial. The source lists quite a few bits found articulated, which is good, meaning they were still connected.
Okay, like what?
Let's see. Parts of the skull, a palatine bone, lower jaws, also a hyoid, which is a throat bone.
Supports the tongue, right?
Yeah. And then a sternum, the breastbone, some belly ribs, part of the pelvis, the right ilium, and then quite a bit of the right leg. Thigh bone, shin bone, calf bone.
So a decent amount to work with, even without a complete skeleton.
Definitely enough to establish it as distinct. And they didn't just look at the bones either.
Oh, what else?
The source mentions it was investigated with a CT scan.
Ah, cool. So they got to look inside the bones without having to, break them.
Exactly. Modern tech giving us insights into fossil structure. It's invaluable, really.
Okay, so we have the discovery, the name, the anatomy, its place in the family tree. What about the timing of all this research?
Well, the description paper came out in 2016. The Wikipedia source actually points this out in context, mentioning the timeline of Oviraptorosaur research, and specifically 2016 in paleontology.
Nice. So you can see where it fits in the bigger picture of discoveries that year.
Yeah. And it also gives a full reference for the paper in the Journal of Vertebrate Paleontology authors title.
Does it give like a link or something for people who really want to geek out?
It does. It lists the DOI, the Digital Object Identifier, and an S2CID number. Those are basically unique codes that take you straight to the scientific publication online.
Perfect. Like leaving a trail for anyone who wants the super detailed version straight from the researchers.
It's great for transparency and further research for sure.
All right, so let's quickly pull this together. We have Apatoraptor, found 93, but mistaken for something common.
Right, an ornithomin, then shelved for years.
And rediscovered, really, in 2008 and finally named in 2016.
Aptly named deceptive thief, Apatoraptor, because of that delay.
And Panatus, feathered, because of those quill knobs on its arm.
Yep, placed it in the Coenobnathidae family, close relative of Elmosaurus, a derived Oviraptorosaur.
It's quite a journey for one dinosaur fossil. That whole aha moment years later must have been something.
Oh, absolutely. It really speaks to the process of science, doesn't it? Things aren't always obvious at first glance. Sometimes you need fresh eyes or new techniques or just time.
Oh, for someone to just decide to reopen that plastered jacket in storage.
Exactly.
Huh.
It shows that our understanding isn't static. We're constantly reevaluating, looking again at things we thought we knew. Paleontology is very much alive in that sense.
And that name, Apatoraptor, the deceptive thief, it just sums it all up so well. Really memorable.
It really does.
It definitely makes you think, how many other finds like this are out there? Sitting in museum drawers, maybe labeled as something else entirely.
It's a tantalizing thought. Fossils that seem mundane might hold secrets.
Just waiting for someone to take that second, closer look. What else is hiding in plain sight in places like the Horseshoe Canyon Formation, or anywhere else for that matter?
Makes you wonder what discoveries are still waiting, doesn't it? Hidden perhaps not in the rock, but in the collections we already have.
A really fascinating thought to end on.